Okay, now we're going to look at operations, and also we're going to do a bit of mathematics. Okay, logical operators, and we're going to do comparison operators as well. Okay, so we'll work on the arithmetics first. Okay, so this, obviously, for those that don't know, plus is plus. So this is for additions. That's a subtraction. That one's multiplication. So if you want to multiply two numbers together, that one's to divide. That one there is modulus. Now I don't really use modulus much. That one's to increment, and that one is to decrement, or to reduce. Okay, so that one's addition, subtraction, multiplication, division, modulus. That's to increment, and that one's to reduce. Let's call it reduce, yeah? So that's you reducing by 1 every time. Okay, so that's fairly simple, and we're just going to take you through logical operators as well. Okay, so that one's and. So if you're doing you're doing a comparison, you're saying this and that should equal something, therefore do such and such. Okay, that one there is the or. That stands for or. So this one's and, okay, and that one's or, and that one is the not. So not equal to something. So fairly straightforward so far. And that's pretty much, so we can do that. Oh yeah, we forgot to do something else as well. That one is equality. So if something's equality, and we'll do examples to illustrate all this as well, so don't worry too much about it. And this one's not equal to, so that one's not equal. That one's greater than, of course, great. And that one's less than. That one's less than, that's greater than, or equal to. So or equal to, and the opposite to that, equal, less than, or equal to. So these are just fairly a few things you might see in the next couple of lessons that we'll do, and we'll do a few examples to illustrate. So shall we get started? Let's go. So we'll start with the very first program, which will do a bit of additions and subtractions and multiplications, so to illustrate the very first arithmetic operators that I showed you in the beginning of the lesson. So we'll start with that. Include stdio.h main, open up int. So we're starting with defining variables. We put a as 4, we got b was 8. Now I just want to do this quickly to make this a little bit clearer for you. I could define the whole thing on one line, or I could have done this, int b equals, like that, yeah? So I could have done that as well. But just to make it, more simpler in appearance, we're just going to do it all in one line. So c equals 1, d equals 1. And what else do we need to put? We need something called a result, or a total, yeah? A plus b, and we're going to print the result of that. So we say printf, and we say added numbers total, %d, so it's a whole number that we're going to print out, and put result. Next, a. So as you can see, result is actually having a different value each time. so we're changing the value. First it's going to be the result of A plus B, and that would put the result into that arithmetic equation would produce a number, and that number will go into result. Now B minus A, so we're subtracting 4 from 8, so I should give it the value 4. Okay, and so on. So you get the picture. Printf. Now we're subtracting. Number puts the result in there, and best thing we do now is we just copy that, and because there's a lot of repetition in here, so we'll just do that. So that's the first section. So we've got the modulus, we've got the division, got multiplication, subtraction, and addition. What else did we mention at the beginning? We mentioned increments and also decrements, so it's reducing the number. So we'll do that now as well. We'll just demonstrate that. Printf, and so we put postfix increment is %d new line, and this time we're going to put C++. So we'll just repeat those two lines again to make it, because there's a bit of repetition. Okay, so we've done that now. Now the postfix of C, so that should give us the value of C after it's done the increment, and here postfix increment, which is the extra that's been added on the C, which would be 1, and that plus what it was before. It was 1 before, so that would produce a 2 here, and here prefix increment, it will actually add an extra 1 to it if we put the plus in front, and that should give us the result 2 straight away. And here postfix increment would be the value it is sitting at now, because now it's a 2, so it would give us another 2 here. So let's see if that would actually work if we run it. So we say save as maths. Okay, save, and now we say run, compile or build. Okay, completed. We'll go back here and we say maths, and it gives us the results. So now it says added the total, which was A and B, A was 4, B was 8, so it gives us 12, and then we subtracted 8, subtract 4, it gives 4, and then we multiplied the 2 together, it gives us 32, and we divided, it gives us 2, 4 from 8 is 2, and modulus, the remainder, if you want to put it that way, after the division is 0. Postfix increment, we're increasing by 1 each time, so we increased the value C by 1, it gave us 2. With D we've actually increased it by 1 straight away, so it's gone to 2, and now the value of D is 2. So that's all working fine. We're going to move to the next example straight away now, and we're going to do one on logic. So we'll do a logical example. Okay, so we'll start with the hash again, include stdio.h, and then we'll put main, open it up, put declaring 2 variables. We'll declare A equals 1, and we'll declare B equals 0. So now we printf and examples. So we've done our first line there. We said give it a tab. We're doing AND examples, so we just put a tab here and we say A and A equals true. So that's true because A equals 1 and A equals 1, therefore it's a true statement. That's the logic behind it. Okay. And now do the B. The F. Now this time we said A and B equals the value. It will return a digital, either it's a 0 or a 1. Now if it's a 1, it means it's true. If it's a 0 this time, it's false. So here we're going to do the comparison. A and B, are they equal to each other? Well, 1 and 0, are they equal? No. So it should return the value 0 and it's false. Put false here. Okay, we'll continue now and we do the last and final comparison in the AND, which is B and B. Are they equal to each other or not? So now we've done B and B. Now I've put false. It should return a 0, but I won't give you the reason just yet. You can guess what the value will be. Comparing B and B, are they equal to each other? Do they return a value 1 or 0? Is it true or false logic? I say it's false, and we'll see at the end what the computer says. Print F. Now we're going to do the OR examples. New line. Okay, so we've now made the OR examples. A or A equals, and it should equal yes, a 1 is true because A or the A has the value 1, so it's true, and that should do the equation there. And we do it here again. A or B is a 1, yes, one of them is a 1, so they puts a 1 there, it's true. B or B, basically both of them are 0, so it shouldn't return a 1, so it's false, which proves why this statement here is false, because two wrongs cannot make a right. Now we continue on to the NOT example. So we put printf, we put NOT examples. Okay, here are the NOT examples. We've put printf and we're saying here that A is not A. Well, is that true? Well, it can't be, because A is A, so that's the logic behind it. So it should return a false 0, which is not true. A by itself, yes, equals is an A, so it should give us a 1, and not A, it is an A, so it should return a 0, a false here. B as well is going to be a 0, because that's the value of B, and not B, yes, it is it is a 0, so it should return the opposite. So it gives us the opposite result that we're looking for. It's not equal to, therefore it must be not equal to. So that's where it becomes a positive, and it's true that B is not B because it is a 0. Confused you yet? Well, let's try the result. So let's save it. Let's say save as compare. Let's call it compare. And we save, and now we say build. Compare. Here we go. A and A equals 1 is true. A and B is not true. it's false because they're not equal to each other. B and B is not equal to each other because two wrongs, like I said, do not make a right, so it becomes a 0. Or examples, we said A or A, yes, they both have the same value. A or B, yes, one of them has the 1, so it returns true. B or B, well, none of them have a 1, so it becomes a 0. And in a not example, A is equal to 1, not A, well, basically that's not true, so it returns a false, because A is 1, and whichever way you look at it is still a 1, and B is a 0, and if the opposite of B is a 1, yes, the opposite to a negative is a positive, so it becomes a true statement. Okay, so that is done. That example is done now. We're gonna try to do an assignment operator just to illustrate how that works.